Hello, my name is Hector Lorenzo, and this is
Alexander Maximchuk.
and we're going to talk today about distributed denial of service attacks. To understand what a distributed denial of service attack is, we need to talk about where it started. And it started as a denial of service attack. Back in the days when the internet was starting and people were moving on to broadband and faster internet connections, everybody had different speeds, and you would be able to have very fast broadband connections as a user. Sometimes was even faster than a corporation or web server. And what this allowed you to do was actually send a bunch of requests to the web server for large amounts of data, and basically overwhelm their connection to the point where it would make them crawl down to a very slow and cause a denial of service attack where legitimate requests couldn't get through. What happened with this was as time progressed, the internet got faster. In fact, nowadays the average network speed is about 40 megabytes a second. So people came out with the idea of distributed denial of service. There's two types of distributed denial of services attacks. There's botnet, which is the one we're going to talk about now, and there's memcache. This botnet attack works as following. Basically, an attacker infects a host network or a controller, which is basically the central hub of information that sends out the instructions to the zombies. The zombies are basically regular user computers like anybody who's on the internet, and they may not know that they're infected. They just feel that their network is slower, and what's really happening here is they're sending requests to the victim, which is a web server, for large amounts of data all at once. So this web server gets hit with all these requests and gets overwhelmed because when it sends out the data, it doesn't go anywhere. All the zombies have their ports closed, their listening ports closed, so they never received any data back, and the victim server just basically ends up getting in a denial of service attack. And there's also another type called the memcache. To understand this attack a little bit better, we need to talk about what a memcache server is. Memcache servers, there's thousands of them on the internet right now, and they're basically sitting there unprotected, and they're used to speed up web page loading, and they're owned by corporations, and they have mass amounts of data. So the way this attack works is actually the attacker spoofs the victim's address and sends a request packet to these servers, which in turn transmit very large packets of data to the victim all at once, causing the victim to end up in a denial of service attack. This is the type of attack that was used for one of the biggest denial of services attacks, which was done to GitHub. And I think at its peak, it was about 1.35 terabytes of data per second that was being sent. It actually caused them to go down for about 10 minutes. So now to speak a little bit more about how to defend yourself against a denial of service attack, Alex is going to take over here.
All right. So defense. DDoS have become quite common lately. Their threat lies not so much in destructive power and it's in denial of service and restricting your access to the applications you need on a daily basis, like banking, medical records, and countless other examples. We will be talking about three proposed methods of defending against DDoS attacks. The first one is threshold-based defense, and the second is cloud environment defense, and the third one is more of a countermeasure than a defense. It's called IP traceback. So to start us off, we have the threshold-based defense. It focuses on detecting harmful traffic on the edge of the network and utilizes entropy, which is calculation done to determine the randomness of the packet flows, and entropy drop value indicates that the traffic is harmful, and when this occurs, the system is alarmed and the system administrator is also notified. Usually the system is implemented on the agent on the outer edge of the network, and this is done in order to detect traffic before it reaches its destination and to drop it beforehand, before any damage is caused. There are several values that are very important in terms of calculating the entropy, and comparing it to the normal mean value. The first one is flow entropy. It's just the probability of the packets that are belonging to the flow, which is marked as XA in this example. Router entropy, it is a collection of entropies from the source and the destination IP address. Then we have the normalized router entropy, which represents the overall distribution of connecting flows. And this is a very important value because it's used as a threshold or normalized value to which the entropy is compared in order to determine if the traffic is harmful or good. Next up, we have the packet rate, which is number of packets sent by the source within a time frame. And lastly, we have the entropy rate, which just estimates the growth of entropy over time. Next, we have the cloud environment. Cloud has become very popular within the last decade, mainly because it allows users to access their data from wherever they need, if they don't have the main machine they're using, which makes them a perfect target for DDoS attacks, because the main goal of DDoS attacks is to deny the service. And this can cause very serious damage. For example, in Medicare, if medical records need to be accessed immediately, or defense system, if a GPS tracking system of the missile fails and is the wrong target, that is a pretty big issue. The proposed defense method is CS DDoS. It operates under assumption that the attacker is not using a spoofed address, and it consists of two parts. The first one is detection, and the second one is prevention. So to talk about detection, all of the incoming traffic and packets are collected, and then they're compared to previously made blacklist from previous attacks. Packets that are not on the blacklist are passed to the classifier, and packets that are on the blacklist are just moved to the prevention section of the system. If traffic is bad or good is determined by a threshold value that can be altered by the system administrator. 4 different classifiers that are used are LS-SVM, which is the most basic pattern recognition classifier. Next one is naive bias, which uses biases theorem to do the pattern recognition. Then we have the k-nearest, which relies on the distance measurement to determine similarities within packets in terms of source and destination. And the last one is multi-layer perception, which uses the feed-forward, and it can be linear or nonlinear depending on how many layers of nodes are used. Okay, and we have the prevention side of the story. The system administrator is alerted, then the source is added to the blacklist, and the packets are dropped. The following algorithm does the assignment. So in this case, if the assigned value is -1, the traffic is abnormal, and if the assigned value is 1, the traffic is normal. Next, we have the IP traceback, and this is more of a countermeasure than a defense. Its main purpose is to identify the attacker and add the source address to the blacklist or whatever. The traffic monitor is on the edge routers. If the packet is considered harmful, the UDP packet is created and assigned to the ingest router. Here we have an image of how the UDP packet looks like, and the little empty and shaded block represents the flag value, which is later on marked as 1 or 0. We'll go over that in a second. The flow monitor determines if traffic is harmful. Harmonic mean is used in calculation mainly because it provides a lower value than the other means, which just ensures that no harmful traffic gets through. The following algorithm is used in the packets. As you can see, the flag values are 1 and 0. If the value of the flag is 1, traffic is harmful. If the value is 0, the traffic is good. So when the corresponding UDP packet is sent back to the attacker, The reconstruction of the address is done in the victim computer or system. And in case that the attacker is using a spoofed address, a hash code runs the source address through the table and compares them in order to determine which one is the real attacking address. So that would be all in terms of defense and the general overview of the DDoS attacks.
Thank you for listening.
All right.